Okay, so today we're going to be going over our system equations and how to solve for x, y, and z. The first thing that we're going to do is we're going to go ahead and we're going to solve for any of the variables from any of the equations. We want to solve for one variable though. And then later we're going to go ahead and plug that into another one. We're going to have two variables solved for, and then we're going to plug into the third equation. So I'm going to pick to solve for x in equation 3. Now, like I said, it could be equation 1, 2, or 3, x, y, or z. Doesn't really matter. Generally, just pick the easiest one, though. So I have 10x plus 20y plus 10z is equal to 0. I'm going to go ahead and move over to the other side, everything but the variable that I'm solving for. So I'm going to have 10x is equal to negative 20y, or yeah, negative 20y minus 10z. Now I'm going to go ahead and divide away this 10 from both sides of the equation so I can get x by itself. So I'm going to be left with x is equal to negative 2y minus z. Next, I'm going to plug what I solved for x into one of the other equations that I haven't used yet. Since I used equation 3 in this last one, I'm going to use equation 1 or equation 2. I'm going to pick equation 2 just because it looks a little bit simpler than equation 1. So what I do is I replace all instances of x in equation 2 with the new value of x. So what I'm going to do is I'm just going to rewrite that equation really quick. Now I'm going to place in what x is equal to. So I have negative 2y minus z. Now you want to keep parentheses around this just in case there is another variable out in front multiplying into these parentheses. Later on we can get rid of them because in this case we don't have anything out there. Now I'm going to go ahead and I'm going to solve for either y or z. It doesn't really matter which one we solve for. In order to solve for this, we're going to need to combine like terms. And what I mean by like terms is we're going to put all the z's with the other z's and all the y's with the y's. We don't really want to mix those together. So we have negative 2y plus the 10y. That's going to leave us with 8y. And then we have negative z plus 15z, which is going to leave us with positive 14z. And that's going to be equal to 20. Now in order to solve for y, I'm going to move over the z and then factor out that 8. So we're going to have y is equal to 20 minus 14z divided all that by 8. If I put this in decimal form, I'm going to have y is equal to 2.5 minus 1.75z. Now we don't need that anymore, any of this work, but what we are going to need is we're going to need this value of y and the value of x, and we're going to go ahead and we're going to plug that back into the third equation. Now in order to solve for this, we only need one variable in the final equation. That way we can solve for it. So as you can notice, the x right here has two variables. It has a negative 2y and a z. Since we're going to be solving for z, we need to get rid of that 2y. Since we just solved for y in terms of z, we can actually plug this newfound y into our x before we plug it into the last equation. So we're just going to substitute those really quick and find a new value for x. So we have x is equal to negative 2y. And we're going to place that y with what we just solved. So we have 2.5 minus 1.75 z, and then minus z. Like I said before, it's really important to keep the parentheses. That way we can go ahead and distribute without in front. So we have x is equal to 2 times 2.5, which is going to be negative 5. And then we have this negative out in front of the 2, and we have a negative in here. That's going to give us a positive. And that's going to be 3.5z minus z. So what we're actually going to have is we're going to have x is equal to negative 5 plus 2.5z. Now we can go ahead and plug this and the y into the last equation and solve for that. Since I've already used equation 2 and equation 3, I'm going to go ahead and use equation 1 to plug those both into. So what I'm going to do now is I'm going to rewrite equation 1. So that was 5x plus 10y plus 20z is equal to 0. Now every time that I have an x, I'm going to replace it with this new value of x that I have down here. And every time I have a y, I'm going to replace it with the new value of y in terms of z down here. So I have 5 times negative 5 plus 2.5z plus 10y, and I'm going to replace the y like I said, with 2.5 minus 1.5z plus 20z is equal to 0. Now what we're going to do, since we only have one variable, is we're going to solve for that variable, and later we'll go ahead and plug that z into the other equations and solve for y and x. Okay, so we're going to go ahead and distribute this 5 and distribute the 10 to everything inside the parentheses. So we have 5 times negative 5, that's going to be negative 25, plus 5 times 2.5, that's going to be 12.5z, plus 10 times 2.5, that's going to be 25, minus 10 times negative 1.75, that's going to be 17.5z, and then we have plus 20 on the end. And that's all equal to 0. What I'm going to do now is I'm going to go ahead and combine the z's together and combine the real terms. Oops, I forgot a z on the end of these really quick, so I'm just going to go ahead and add that back in there. This 25 and this 25 is going to go ahead and cancel out, so we're going to be left with, let me add these up. So we're going to be left with 15z is equal to 0. Whenever we go ahead and divide away that 15, we're still going to have z is equal to 0. So now what we can do is we can go ahead and we can plug this z back into either of these y or x equations and solve for x and y. So I'm just going to grab one of these equations that I have right here. I'm going to choose the y first. So I have y is equal to 2.5 minus 1.75z. And we're going to plug z in for the 0 that we have. So now we have y is equal to 2.5. We're going to do that same exact thing with the x. Okay, so if we go ahead and plug the z into x, we're going to have x is equal to negative 5 plus 2.5z. And since z is equal to 0, we're going to have x is equal to negative 5. If we wanted to check these answers, what we could do is we could plug them into one of the system of equations that we had, either the first one, the second one, or the third one.